Alright, last example. I want you to write the polynomial below as a product of first degree factors, and I'm giving you the fact that 1 is a 0 of multiplicity 2. So use that knowledge, don't use your calculator, to write this as a product of first degree factors. So pause the video and unpause it when you're ready to check your answer or if you're stuck. Okay, so if I know that 1 is a 0 of multiplicity 2, I'm going to do synthetic division with 1, and I'm going to do it twice because it's multiplicity 2. Now again, remember, we can always do long division, or you could multiply out x minus 1 times x minus 1 and do long division with that product to get right to another quadratic. Any of those step methods will work. This is what I chose to do. So I do synthetic division with 1 at first, and I get 1, negative 2, negative 5, 6, 0 as a remainder. That tells me that I did this correctly. And then I can just go ahead and set up the next synthetic division right away with this cubic polynomial. So I do synthetic division again, I get 1, negative 6, and then 0 again as a remainder. So again, that tells me I did this correctly, and it's nice to know that I didn't lie to you, that 1 was a 0 with multiplicity 2. So now this is a quadratic because I've done synthetic division twice, and this is x squared minus x minus 6. This factors into x minus 3 times x plus 2. Now remember, the question or the problem wanted us to write the polynomial as a product of linear factors or first degree factors. So I don't need to actually find the zeros, even though I know what they are at this point also. So to write my answer, I'm going to write this as x minus 1 times x minus 1 times x minus 3 times x minus 2. Times x plus 2. So that is a product of first degree factors. Alright, so then just to kind of conclude what we did in this lesson, we understand the different powers of I and how we can use those to find any power of I. The standard form of a complex number is very important. That's written as a plus bi, where we have the real part and then the imaginary part. When adding or subtracting complex numbers, we just combine like terms. When dividing complex numbers, multiply by the conjugate of the denominator.